Welcome to Unit 6 entitled Temperature and Heat. In this section of the unit we're going to focus on subsection 6.3 entitled Temperature Scale. Students will be expected to read a thermometer. So let's begin by looking at how you would make a thermometer. In order to make a thermometer, you need to have two fixed points of temperatures of the body that you're taking the temperature of. So in order to make a thermometer, you need to identify two fixed points on the thermometer which relates to the temperature of the body. And this must be marked on a thermometer scale board. So the distance between the two fixed points, they must be divided by sections of equal lengths. And these two fixed points, they are the lower fixed point, which would, in the case of ice or water, this would represent the melting point of ice. In other words, ice melts at a temperature of 0 degrees Celsius. And you could also have an upper fixed point, which would represent the boiling point of water at sea level, and that would be 100 degrees Celsius, which is the temperature that the water will boil. Essentially what you're doing is that you're marking out the fixed points of temperatures relating to the temperature at which water freezes, so that will be identified as the lower fixed point or the melting point of ice, and you would mark that out on a card, and then you'd have the upper fixed point, which is the temperature at which the water boils, and so you'd mark that out also on a card. So the three common temperature scales are the Celsius scale, which is 0 degrees in terms of the lower fixed point, and 100 degrees, which is the upper fixed point. And then for the Fahrenheit scale, you have the lower fixed point of 32 degrees Fahrenheit and the upper fixed point of 212 degrees Fahrenheit. And for the Kelvin scale, you have the lower fixed point of 273 degrees and the upper fixed point of 373 degrees for the Kelvin scale. What you would do now, if you look at the diagram, is you just put these all side by side. And so in the diagram, what you would have is for the corresponding upper fixed point for the Celsius thermometer, which is 100 degrees Celsius, that corresponds to the upper fixed point of 373 Kelvin for the Kelvin thermometer and 212 degrees Fahrenheit for the Fahrenheit thermometer. And in terms of the corresponding lower fixed point for 0 degrees for the Celsius thermometer, that would correspond to 273 Kelvin for the Kelvin thermometer and 32 degrees Fahrenheit for the Fahrenheit thermometer. And you can see here that as we go below 0 degrees Celsius, we can show the corresponding points for various temperatures in degrees Celsius in terms of how they relate to temperatures in Kelvin and temperatures in Fahrenheit. So how do you read a thermometer? So to read a thermometer is quite straightforward. For example, if we have this diagram representing the temperature scale in Celsius, in other words the Celsius thermometer, all you would do is to determine the reading, for example, at this point here, you would just look at the corresponding value for the temperature in Celsius as it corresponds to the level of the actual liquid inside the thermometer. So here you can see that this would represent 50 degrees Celsius. This area here would represent 20 degrees Celsius, and this would represent 0 degrees Celsius. So that's how you would read a thermometer, just aligning your eyes along the level of the liquid in the thermometer and then looking at the corresponding value in terms of the reading in degrees Celsius. Welcome to Unit 6, entitled Temperature and Heat. In this part of the unit, we're going to focus on section 6.4, which is the section entitled Conversion of Temperature Scales. Now, temperature is a measure of the hotness or the coldness of something, some material. However, temperature is not the measure of the total amount of energy contained in that material. So temperature is measured in degrees Celsius, or sometimes it's measured in what's called centigrade, which is the same thing. It's just different ways of expressing temperature in terms of degrees C. And the freezing point of water is defined as 0 degrees C, or 0 degrees Celsius, or centigrade, and that's the freezing point at 1 atmosphere pressure. The boiling point of water is defined as 100 degrees C, or 100 degrees Celsius, or centigrade, and again, that is the boiling point at 1 atmosphere pressure. And temperature can be measured in a variety of different ways, using different thermometers. And these types of thermometers include, for example, ones that we're familiar with in the laboratory, and that is when you have a liquid in a glass. For example, in the old days that used to be mercury, but now there are different types of colored liquids which are used in these thin tube glasses that we call thermometers. But there are also other types of thermometers, and they are, for example, what we call digital thermocouples. And another type of thermometer is a bimetal strip thermometer. In order to convert temperature scales from, for example, Fahrenheit to Celsius, or Celsius to Fahrenheit, or even Celsius to Kelvin, we can use a series of conversion expressions. So, for example, if we wanted to determine the temperature of a substance in Fahrenheit, but we know its temperature in degrees Celsius, we can use the expression that F is equal to 9 divided by 5 multiplied by the temperature in Celsius plus 32. So that expression would give us the temperature in Fahrenheit. And if we wanted to determine the temperature in Celsius, and we know the temperature in Fahrenheit, we can say that the temperature in Celsius is equal to 5 over 9 multiplied by, and we have a bracket, the temperature in Fahrenheit minus 32, close bracket. And if we wanted to determine the temperature in Kelvin, and we know the temperature in degrees Celsius, we can use the expression that the temperature in Kelvin is equal to the temperature in Celsius plus 273. So these are the typical conversion scales for temperature in terms of Fahrenheit, Celsius, and Kelvin. And you're going to be using these in the following worked examples. So let's have a look at the first worked example. The temperature of a body is measured as 50 degrees Celsius. Find out the temperature of the body in Fahrenheit and Kelvin. So let's go through this one together. You're given that the temperature in Celsius, degrees Celsius, is 50 degrees Celsius. And you're required to find F, the temperature in Fahrenheit, and you're required to find K, the temperature in Kelvin. So what we would do to determine the temperature in Fahrenheit is to use the expression F is equal to 9 divided by 5 multiplied by the temperature in degrees Celsius plus 32. And if we substitute in the values for the temperature in Celsius, which is 50, into the expression, we get that the temperature in Fahrenheit is equal to 9 over 5 times 50 plus 32, and that will give us a value for the temperature in Fahrenheit of 122 degrees Fahrenheit. And similarly, if we wanted to determine the temperature in Kelvin, we would use the expression that K is equal to C, which is the temperature in degrees Celsius, plus 273. And the temperature in Celsius is equal to 50 degrees. Therefore, the temperature in Kelvin is equal to 50 plus 273, and that will give us a value for the temperature in Kelvin of 323 degrees Kelvin. So let's consider another worked example. Convert 200 degrees Fahrenheit into Celsius and Kelvin. So we're given that degrees Fahrenheit is equal to 50, and we're required to determine the temperature in Celsius and also in degrees. So to determine the temperature in degrees Celsius, we just use the expression that the temperature C in degrees Celsius is equal to 5/9, and then we have bracket the temperature in Fahrenheit minus 32 close bracket. And if we do that, we get that the temperature in degrees Celsius is equal to 5/9 multiplied by 50, and that's in bracket, minus 32 and the close bracket. That will give us a value for the temperature in degrees Celsius as being equal to 15 degrees. And similarly, we can work out the temperature in Kelvin by using the expression that the temperature in Kelvin is equal to the temperature in degrees Celsius plus 273. Well, we've just determined what the temperature is in degrees Celsius. That is 15. So we can then add 15 to 273, and that will give us the answer for the temperature in Kelvin as 288. Now this is an interesting worked example. The question is, at what temperature does the Fahrenheit and the Celsius scale have identical readings? So in other words, what we're asked is, when is the temperature in degrees Celsius equal to the temperature in degrees Fahrenheit? Okay, in other words, what is the temperature that they have the exact same reading? So what we need to do is we need to use the expression that the temperature in Celsius is equal to 5/9, and then bracket the temperature in Fahrenheit minus 32 close bracket. But this time what we're going to do is we're going to put the temperature in Fahrenheit as C, because we want to know what will be the temperature in degrees Celsius when it's identical to the temperature in degrees Fahrenheit. So if the temperature in degrees Fahrenheit is the same as the temperature in degrees Celsius, then this value here will be C. So we put that in, and then we derive an expression, which is an equation, a linear equation, which basically is that 9C, when we bring the 9 from here over to this side here where we have the C, 9C is equal to 5C minus 5 times 32. So what we do is we rearrange the expression, and we get 4C is equal to minus 160. Therefore, that gives us a value of C being equal to minus 40 degrees. In other words, the temperature in Fahrenheit is equal to the temperature in Celsius when the value is minus 40 degrees. Write the mathematical relationship between Celsius and the Fahrenheit scale. And then the second part of this question is to convert 56 degrees to degrees Fahrenheit in Kelvin. And the third part of this question is to convert 210 degrees Fahrenheit to degrees Celsius and Kelvin. So have a go at these series of questions, and then write your answers in your exercise book. And then when you're ready to compare your answers with the answers in the solution, then you can press the play button. So first of all, pause the video have a go at the questions, then press the play button to compare your answers to that of the answers provided in the solution. Okay, so let's have a look. The answers are as follows. The expression for converting degrees Celsius into degrees Fahrenheit is given by F is equal to 9/5 multiplied by C, the temperature in degrees Celsius, plus 32. And for the second part of the question, we can determine F, the temperature in degrees Fahrenheit, if we know the temperature in degrees Celsius, and we're given the temperature in degrees Celsius is 56 degrees Celsius. So we substitute the value for C, and that value is going to be 56. So in the second part of the question, you're asked to determine the temperature in Fahrenheit, given that you have a temperature in degrees Celsius of 56 degrees. So that's simply the case of you just substituting into this expression the value for C equal to 56. And if you do that, what you get is that the temperature in degrees Fahrenheit will be 9/5 times 56 plus 32. And so that will give you the temperature in degrees Fahrenheit equal to 132.80. And in the same way, the temperature in Kelvin will be equal to the temperature in degrees Celsius, which is 56, plus 273. And so that will give you a value of 329 Kelvin. So in the third part of the question, you're asked to convert 210 degrees Fahrenheit into Celsius as well as into Kelvin. So in order to convert 210 degrees Fahrenheit into Celsius, we just substitute the value for the temperature in Fahrenheit into this expression here, that the temperature in Celsius is going to be equal to 5/9, open bracket, the temperature in Fahrenheit minus 32, close bracket. And if we substitute the values in, we get that the temperature in degrees Celsius will be 5/9, open bracket, times 210 minus 32, where 210 is the temperature that we're given in degrees Fahrenheit. So that will give us a value for the temperature in degrees Celsius as being equal to 98.8 degrees Celsius. And to determine the temperature in Kelvin, we just use the expression that temperature in Kelvin is equal to the temperature in Celsius plus 273. And we know what the temperature is in Celsius. We've just worked that out to be 98.8 degrees Celsius. So the temperature in Kelvin is 98.8 plus 273, and that will give us a value of 371.8 Kelvin. Welcome to Unit 6, entitled Temperature and Heat. This particular part of the unit is going to focus on subunit 6.5, entitled Resources of Heat. We need to actually understand what is a definition of heat. Now you can see from the bracket here that the symbol for heat is given as Q. And this is very important because in physics we tend to use this symbol to represent heat loss from a system or heat gained by a system. And we tend to relate it to an expression which involves the mass of the substance which we're measuring the heat of, and something called the specific heat capacity, which we'll talk a little bit more about a bit later on, as well as the temperature difference of the substance. So for example, if that substance experiences a temperature change, let's say of 10 degrees Celsius to 20 degrees Celsius, that means it increases in energy, in thermal energy, then we can write down a definition of heat which is related to that change in temperature. But much more about that as we go through the unit. We also need to understand the units of heat. We also need to be able to distinguish between heat and temperature. And this is something that a lot of students tend to mix up. Heat and temperature are actually different in terms of what they represent and in terms of their definition. We need to also look at the sign convention for heat energy transfer. In other words, sometimes you can get a value for Q which is negative, and that basically tells you that heat is being released into the environment. So in other words, when Q is less than 0, we can say that heat is given out from the substance to the environment. And then when heat is absorbed from the surrounding, we can refer to this in such a way by putting a positive sign in front of the value for Q. And that tells you that the substance is taking heat energy from the environment. And we'll have a look at what this means in terms of practical examples. And then finally, we also need to know ways in which heat transfer occurs. And this means looking at what is the difference between, for example, convection, conduction, and radiation. So we're going to be exploring these 3 different types of heat transfer. Okay, let's start by looking at